Hey everyone, in this mini lecture we're going to take a look at the product rule and quotient rule for differentiation. So let's take a look at that product rule first. So if we have a product of two functions and we're told to take the derivative, we do so by taking the derivative of the first function and multiplying it times the second function and then adding that to the first function being multiplied times the derivative of the second function. Then we next have the quotient rule. The quotient rule says that if you have two functions, we'll call them f and g, and then you want to take the derivative of them, the quotient of those two functions, then the formula says to take the derivative of the function that's in the numerator times the function that's in the denominator minus the function in the numerator multiplied times the derivative of the function in the denominator. Draw your fraction bar or division bar and take what's in the denominator and square it. So we have what's known as the product rule and also what's known as the quotient rule. The product rule and quotient rule, very important for us. So let's take a look at our first example. We have y equals the cube root of x squared times the quantity of 2x minus x squared. All right, so it looks like to me that we have two functions, right? The cube root of x squared is one function, and it's being multiplied times the other function, 2x minus x squared. So that's how we identify the f and the g. So just recall the product rule, right? Just have it written down right next to you until you do many problems and then eventually, okay, you come to memorize it. So the product rule says to take the derivative of the first function. Well, first, maybe we should make things a little bit easier for us, right? So whenever we have a radical, when we're doing calculus, we should try to change that to something with a rational exponent. So what is that? That becomes x to the 2/3 power by definition, right? That index becomes the denominator. What you're raising that variable to, or that radicand to, becomes the numerator. So that's x to the 2/3 power, and then that's times 2x minus x squared. So it's still our f, and what's in parentheses is our g. Still two separate functions, but x to the 2/3 power makes it a bit easier, and now we can apply what we've learned before in a previous video or previous course, previous class meeting, I'm sorry, which is the power rule. So looking at the power rule, we would say y prime is equal to, power rule says to make this 2/3 go in front of the x, and then we're going to subtract 1 from 2/3. So subtracting 1 from 2/3. So 2/3 minus 1, 1 is written as 3/3. So we can say 2/3 minus 3/3. So that makes a negative 1/3. And then we've done that part. So now it says multiply times the other function, which is 2x minus x squared, right? And then the product rule says to go ahead and add that to that first function, now x to the 2/3, and multiply times the derivative of the second function. So the second function is 2x minus x squared, where the derivative of 2x is just 2, and the derivative of negative x squared is negative 2x, right? Using the power rule, and also maybe telling ourselves that we subtract that 1 from the 2, so that'll be x to the first, and you can choose to write the 1 as the exponent or not. So we've applied the power rule, and now what we can do is to clean things up a bit. What I would do next is just go ahead and probably distribute that 2/3 x to the negative 1/3. And in distributing that, 2/3 times 2, we'll get 4/3. X to the negative 1/3 times the x to the first power. X to the first power is like saying 3x to the 3/3 power, right? Because we have to rewrite the 1 as a fraction. So negative 1/3 added to 3/3, because we're using properties of exponents. When you have the same base, you add the exponents. So that's negative 1/3 plus 3/3 becomes 2/3. And now we're going to distribute 2/3 x to the negative 1/3 times negative x to the second power. So that's going to be, for us, a negative 2/3, negative 2/3, and it's x. And then again, we're adding the exponents, negative 1/3 plus 2. 2 is really 6/3. So negative 1/3 plus 6/3 is 5/3. And then I'm just going to distribute as well right here. So that one is going to be simply 2x to the 2/3, right? And then we'll have a negative 2x, and now we have to add 2/3 plus this 1, this x to the first power, which is a 1, so that's 3/3. 2/3 plus 3/3 is 5/3. The next thing I could do is combine like terms, right? These two are like terms. Like terms, remember, are terms that have the same variable and the same exponent. So like terms are also these two right here, right? So now finally I can say that we have y prime being the combination of these terms, 4/3 x to the 2/3 and 2x to the 2/3. So I'm simply adding 4/3 plus 2. So we rewrite 2 with a denominator of 3, right? So that'll be 6/3. So 4/3 plus 6/3 is 10/3. And then we're just writing x to the 2/3 power. X to the, and now I'm going to combine the other like terms. What were they? Negative 2/3 x to the 5/3 and negative 2x to the 5/3. So I'm combining the negative 2/3 and negative 2. So when I add those together, I get a negative, and 2 written as a fraction can be 6/3. So 2/3 plus 6/3 is going to be, I'm sorry, a negative 2/3 and a negative 6/3 is a negative 8/3. And then we rewrite the variable with the same exponent. All right, so now we have y prime is equaling 10/3 x to the 2/3 power minus 8/3 x to the 5/3 power. So we've obtained the derivative using the product rule. All right, in this next example, we have f of x is equal to 4 over x to the 6th power. So right away you're looking at that, and maybe you're saying to yourself 4 over x to the 6th. That's division, so we'll apply the quotient rule. So let's go and do that, and then I'm going to show you another way as well after we're finished using the quotient rule. So let's use the quotient rule, and first I want to recall what the quotient rule was. So here we have the quotient rule. I've rewritten over here to the right, f over g prime. So what we do is take the numerator, the function in the numerator, its derivative times the denominator, that function, minus the function in the numerator times the derivative of the function in the denominator. Make your fraction bar, your division bar, and divide by whatever your denominator is squared. So let's go ahead and apply that. So the derivative of the numerator, that 4, is 0, right? We said before in a previous lecture or previous mini lecture and video that the derivative of any constant is 0. And that's times g. G is just the actual denominator. Don't take the derivative of that according to the formula. And then we place a minus sign in between. The next product is just taking the numerator, that function, which is 4. And then g prime says to take the derivative of the denominator. So taking the derivative of x to the 6th power, not too bad, just use that power rule we've learned already. So that's 6x to the 5th power. And then the quotient rule says to draw your line and square whatever your denominator is. And we do that. All right, so we've just applied the quotient rule. So now we can just clean it up a bit. So we'll say f prime of x is equal to 0 times x to the 6th power. That just gets us 0, right? And then we say minus 4 times 6x to the 5th. Well, negative 4 times 6x to the 5th is negative 24x to the 5th. And remember, 0 times x to the 6th is 0, so we don't have to write that part. And that's all over x to the 6th raised to the 2nd power. So when you raise a power to a power, laws of exponents says to multiply the exponents. All right, and then lastly here, we can go further and say to ourselves, okay, we have x to the 5th over x to the 12th. That should tell you to go ahead and use some properties of exponents, right? So you're always going to take the top minus the bottom. So 5 minus 7 is, what's that, negative 7. However, we don't want any negative exponents. So I'll finish this out and say to ourselves that negative 24 will be on top. We'll put the x to the 7th in the denominator, and that way the exponent becomes positive. So f prime of x, meaning the derivative, is equal to negative 24 over x to the 7th power. Okay, and I told you that we were going to rework this problem another way. So we have 4 over x to the 6th power. So remember, in calculus, you always want to use other skills to try to simplify your problem and make things easier as far as the calculus. So what I would do, I would say to myself, let's go ahead and rewrite this 4 over x to the 6th. I can move that x to the 6th to the numerator, right? If I make it x to the negative 6, remember that? Properties of exponents again. So now looking at this, I can go back to what we learned earlier in that constant multiple rule. And I can say, okay, let's take that 4 out and then just take the derivative of x to the negative 6. Well, take the derivative of x to the negative 6, we'll just use that power rule. So the power rule says to make it negative 6x, right? Bring that exponent to the front of the variable and then subtract 1. Well, negative 6 minus 1 will make it negative 7, right? And then now you can go ahead and multiply that 4 times the, 4 times the negative 6 is negative 24, and then you have x to the negative 7. But remember, we don't want negative exponents, so we'll still make it negative 24 over the x to the 7th comes to the denominator. So we get the same answer as we did above when we used the quotient rule, but here we moved the x to the 6 up next to the 4, and we were able to use other more basic rules for differentiation.